welcome to topic 1.1. Okay, that is on the vapor compression cycle. In this topic, I'm going to cover the very basic and fundamentals of the vapor compression cycles and the working principle behind air conditioning system. Without understanding the working engine behind air conditioning, it's very hard to analyze and also to improve on this cycle. So I will cover a few topics, okay, the main few topics that is on laws of thermodynamics, okay, heat transfer, refrigerant cycle, as well as the property of different refrigerant. What is laws of thermodynamics? Or in fact, what is thermodynamics? Okay, it's actually the physical science between heat and other forms of energy. As we know, there are different forms of energy, such as light energy, electrical energy, sound, and heat is one type of energy. So thermodynamic, if we break this word into two, thermo is referring to heat, such as thermometer, okay, it's a measuring of the amount of heat in the body, okay, and dynamics is actually means movement. So all in all, thermodynamics means movement of heat, and that's the law that we are going to study. There are total 4 laws of thermodynamics. Okay, we are not going into details of each and every single law, and you don't have to really go and memorize what is the definition of each law. Okay, but we will use the first 2 laws, okay, first law and second law, to explain the working principle behind vapor compression cycle, okay, which is a cycle that is able to produce coolness and produce air conditioning. So first law of thermodynamics, okay, is actually law of conservation of energy. So what is conservation of energy? It means energy can be transformed from one form to the other. For example, okay, you can have heat energy transformed to maybe light, okay, or electrical energy, okay, transformed to heat and sound, okay. So this is what we mean by transformation, conservation of energy. The left-hand side values, okay, must be equal to the right-hand side. Okay, in other words, you cannot create energy out of nothing, or you cannot destroy energy. Okay, they can only be transformed from one form to the other. That's on first law of thermodynamics. And there's a there's an equation, okay, that governs this law, okay, that is Q plus work done on gas is equal to change in internal energy. Okay, so what is Q? Q actually means the amount of heat you put into a system. Okay, the amount of heat into a system. So for example, if you heat up a gas, okay, a piston cylinder kind of setup, okay, and you heat it up using a Bunsen burner, okay, so the amount of heat energy that put into the gas is actually represented by this Q value. Okay, how about what is W on? Okay, why is there a subscript on? So W on means the amount of work you do onto the gas. Okay, work done on the gas. In other words, work done on gas is compression process. Okay, so let's say a gas initially contains this amount of air, amount of gas inside. Okay, if you push down the piston, okay, you push it down, the air will get compressed. So the amount of work you done onto the gas, that is W on. Okay, so what if it's an expansion process? That means instead of pushing down the piston, you pull up the piston. If it's an expansion process, okay, that is work done by gas. Okay, work done by gas. So there's a difference between work done on gas and work done by gas. And finally, what is change in U? Okay, in physics, we always use this symbol, triangle, to represent delta or change in. So if it's delta U, it means change in U, okay, and U represent internal energy. This U represent internal energy. So all in all, okay, it means if you heat up the system, okay, if you heat up a piston cylinder system, and at the same time you push down the piston, okay, the amount of heat, okay, the amount of energy you give to the gas is the change in internal energy. Okay, so internal energy is actually just the total energy contained in the system. It includes the molecular, kinetic, and potential energy. So one very quick example, let's say the amount of work you do here is 5 joules. Okay, the amount of heat you put into the system is 10 joules. Okay, that is to say the change in internal energy will be 10 plus 5, 15 joules. Okay, so that's how you use this equation. So that's on first law of thermodynamics. Okay, now I'll talk about second law of thermodynamics. Okay, second law of thermodynamics, it means heat will always flow from a hotter body to a colder body. Okay, it happens so naturally that we don't really think much about it. Okay, we know that it's very normal. So for example, if you have something over here, okay, and this thing is very hot, okay, 30 degrees Celsius, okay, and you have another item over here, okay, that is 15 degrees Celsius. So how will heat transfer take place? So heat transfer, when we use the word transfer, it must be from point A to point B, from somewhere to somewhere. So in this case, this object has a higher temperature, so it will move from this direction to this direction. Heat will transfer from the hotter body to the colder body. And it will happen naturally. You don't have to do anything. It will just happen until both of them reach equilibrium. Maybe at around, maybe after some time, it becomes 22 degrees Celsius. And the colder body also gets heated up, okay, and become 22 degrees Celsius. That is when you reach thermal equilibrium. So at this point of time, there will be no more heat transfer and everything will have the same temperature. Okay, what if you, let's say back to the first scenario, 30 degrees Celsius, and you have 15 degrees Celsius. What if I want to make this object colder? That means I want it to become 10 degrees Celsius, and I want to make this object hotter, maybe to 40 degrees Celsius. So how can I make a hot object even hotter, or make a cold object even colder? It will not happen naturally. Okay, you have to do something to it to make this happen. That is, you have to have external work. Okay, you have to do some external work by having a device. Okay, having something to trigger this process. So that is actually the idea of what is second law of thermodynamics.